My name is Ariana Novelsky, and my project is the effect of aspartame and neotame versus sucrose on SLC2A9 gene expression. On average, adults and young adults in the U.S. consume about 17 teaspoons of added sugar daily. This adds up to over 60 pounds of added sugar annually. This has contributed to an increase in diabetes and obesity cases. To alleviate this, artificial sugars have increased in popularity and are considered free food containing under 20 calories, 5 grams of carbs, and 0 grams of sugar in them. Unfortunately, these sweeteners are not as perfect as they seem. Aspartame, for example, a common artificial sweetener, is linked to kidney and liver damage and is possibly carcinogenic. So, to curb this, neotame was developed as the perfect solution. It was made by N-alkylating aspartame, which pretty much just adds an extra alkyl group. This makes it much sweeter and more chemically stable. Additionally, in neotame, methanol is a minor product versus in aspartame, it is a major product. So neotame should be healthier than aspartame. Unfortunately, it is much newer and it is less researched, so not much is known about it. To truly test the effect of these sweeteners, I followed a couple of steps. First, I cultured HEK29T3 cells, which are just kidney cells, and I let them grow until they reached 80% confluence. Once they reached this level of confluency, I passed the cells, which means I transferred them to a new container so they could continue growing, and I treated them with my treatment solutions, which were neotame, aspartame, sucrose, as well as a control with nothing in it. Then I extracted RNA, which is just a single-stranded version of the genetic code, and to test the RNA quality, I used a spectrometer. Afterwards, I transcribed it to cDNA, which is a double-stranded version of the genetic code, and to target my specific region that I wanted to target, which was the SLC2A9 gene, I used both forward and reverse primers. Afterwards, I ran a qPCR test to get quantitative data, and then I conducted an ANOVA test to get further data on that. So what does the SLC2A9 do? The SLC2A9 gene is a major urate and glucose transporter. Its main function is to secrete and reabsorb urate back into the blood. Urate is just a waste product made by the body. Artificial sweeteners like neotame and aspartame can lead to overexpression of this gene, which can lead to increased urate reabsorbed into the bloodstream. This can lead to urate crystals, inflammation, as well as just kidney damage. Future implications of this can lead to stricter regulations and just healthier choices made by consumers. Thank you for listening.